thank Gabriella and her parents, and her mom is here, and all of the patient advocates. Your dedication to your families and your holding the research community to account is a powerful driver of progress. Those of us in pediatric research know how special our mission is. It is our hope that the Kids First program will be an accelerator for discovery, helping uncover the causes of childhood cancer and structural birth defects, with ultimately the translation of those findings into improved diagnostics and more effective therapies. We also believe that the Kids First program can be a model for the broader scientific community on how to share data and collaborate across disciplines within an open data ecosystem, with the goal of empowering data generation and dissemination. We look forward to this vision becoming a reality. It's now my pleasure to introduce Dr. Gary Gibbons, who will provide a formal welcome from the NIH. Dr. Gibbons is the 12th director of the NHLBI since its founding in 1948. Prior to coming to NIH, Dr. Gibbons led the Cardiovascular Research Institute at Morehouse School of Medicine, where he directed research in the fields of vascular biology, genomic medicine, and the pathogenesis of vascular diseases. I'd like to note that Dr. Gibbons has been actively involved in the Kids First program since its very beginning in late 2014, when we first learned of the legislation. In fact, Dr. Gibbons led some of the early discussions where the idea for a pediatric-focused data commons was germinated. He has been a strong advocate for the program ever since. With that, I'd like to welcome Dr. Gibbons.
We didn't have to applaud. It's too early in the morning for that. It's really my honor to be here because this is a very exciting program. It's an exciting day of launch for all the components coming together. And it's really my pleasure and privilege to stand in for my colleague co-chairs, Dr. Bianchi of Child Health, and Dr. Lowy of NCI, and Larry Brody from the Genome Institute. Collectively, we co-chair this program oversight. Fortunately, as IC directors, we actually don't do any work because we have great staff that you've all engaged in who are providing all the energy and direction and management of this program. It is one that really comes to the heart of our mission of turning discovery into health, and with a particular focus around the most vulnerable population, our children, and really a great opportunity for us to fulfill our mission through partnerships. Obviously, everyone in this room, clearly its genesis is a partnership that really bubbled up from the patient advocates that are here today. And it was a great pleasure to meet Ellen Miller this morning and to feel that passion and inspiration for this whole great opportunity. And she excited me even more that her visions are grander for this program. This is just a beginning. And that's how we see it as well, as a very patient-centered kind of research program where we're delighted to be held to account by that high inspiration that Gabriella has provided us. I'm also excited about the scientific progress that's been made in a very short period of time. I'm told we're up to 18,000 sequences that are moving through, and really on the precipice of launching the data commons at Resnick and others, and really some important steps forward that I think are paradigm breaking. I'm an adult cardiologist, so I apologize for interloping amongst the pediatric types here, but I've been inspired because in my field we tend to study things by organ, and the oncologists have taught us so much about disease processes. Basically, cancer is a genomic disorder, mutations, and how indeed maybe that's telling us something about these structural birth defects. Some of them may be caused by these spontaneous de novo mutations that set a perturbation in the genetic programs important for organ development. And you all are are leading us into those exciting new insights, understanding the genetic programs that, in our case, form the heart and what that might tell us about commonalities about formation of the brain and intellectual disabilities and neurological defects, and the commonality that may involve that really transcends organ and gets into molecular processes. We're hopeful that you're going to provide us with those really groundbreaking scientific discoveries. And that's, again, why we're very excited about the inception of this program, particularly its capacity to promote a model of data sharing, as John alluded to, through the data commons. Because what better way to bring new knowledge and to bring these fields together that transcend the organ, but by providing those data sources to allow us to trace those commonalities in disease processes that really aren't bound by an organ and a part of syndrome. So we look forward to the inception of the data commons and the data science that will drive the next stage of this program. So again, it's my delight to welcome you. I already feel a lot of the energy that's coming from the synergies that are part of the collaborations that are unfolding. And I regret that I can't be here throughout the whole meeting today, but we're looking forward to a lot of work in progress and the acceleration of discovery of this space. So again, thank you for your engagement, providing your expertise, and your willingness to share this with a broader community to fulfill the vision and inspiration of Gabriella Miller. Thanks again.
So I'm Malcolm Smith from the NCI, and it's a pleasure to welcome you to this meeting on behalf of NCI and on behalf of Dr. Lowy, our acting director, who had other things he has to attend to today, but sends his support for this project. And of course, I need to acknowledge Ellen Miller as well, and all she's done to bring us to the point that we're at today. And all the advocates who support and advocate for research on these serious conditions that affect children. So there are some of us in the room who've been working on this project for a few years now, and we are excited to be at this point, to have the team from CHOP in place as the data resource, to have the two sequencing centers on board, and larger and larger volumes of sequencing data becoming available, and to have all the EXO-1 teams, and to seeing how we build bridges between the research teams working on birth defects and the research teams working on cancer. So this is a really important day for us. So I obviously come from a childhood cancer background, and collaboration is baked into our DNA. It's not that we're particularly virtuous. It's just that in order to have enough children with any given clinical diagnosis to come to meaningful conclusions about how to classify the cancers, how to treat the cancers, our founders recognized 5 or 6 decades ago that you had to collaborate. You had to bring institutions together, multiple research teams. So this is really central to us. And over the last 10 years, as genomics has been introduced into childhood cancer research, it's only become more and more clear that this collaboration is necessary. Entities that we thought were relatively homogeneous, we now know are composed of multiple, very distinctive subtypes at the molecular level. And so the proverbial pie is being sliced into smaller and smaller pieces, and the need for larger and larger collaborations becomes important. And indeed, if you look over the last 5 years, some of the most important advances have been made by research teams that realize they really need to put collaboration on steroids and to get not 100 patients with a rare disease, rare cancer, but 1,000 patients. And there are many examples I could give, but one would be medulloblastoma, a tumor in the cerebellum of children. 20 years ago, medulloblastoma. 5 years ago, clearly there are 4 distinct types of medulloblastoma, each with their own clinical presentation, their distinct molecular characteristics. And today, with more patients with more genomic characterization, probably 10 entities at least within medulloblastoma. And again, each distinctive clinical presentation, distinctive characteristics. And importantly for this discussion today, some of these have clear genetic predispositions within these subsets. So we are really true believers in terms of collaboration and data sharing. And it is one of the reasons that we're so excited to have the Kids First Data Resource beginning its activities. We know that this is a major task. There are informatics challenges. There are huge challenges in terms of phenotypic harmonization across these multiple types of diseases. And we recognize there are multiple skill sets that are going to be needed to address all of these challenges. But these skill sets are well represented in the team that Adam has assembled, and they're well represented within the EXA-1 recipients who are here today. And so we do look forward to great work through these efforts and to a good start in the next 2 days. And I will now let us get to the real work of these 2 days and turn it over either to Valerie or Lorette. Okay, thanks.
So good morning, everyone, and let me add my welcome too, and just to point out that we all here at NIH have been working on this for over 3 years, and it's really great to have all of you in the room because there's many of you that we've been communicating with via email for many years, and it's really fun to actually get to meet you in person at this meeting. So I'm happy to be representing the NIH program staff. There are over 50 of us that are involved in the Kids First program, and I'm going to present today an overview of what's been accomplished so far with the program. By way of background, for those of you who are unaware, the Gabriella Miller Kids First Research Act was signed into law by President Obama in 2014. And this bill actually did 3 things. It ended taxpayer contribution on the face page of the 1040, which is there in the bottom of the screen. There used to be a checkbox circled in red that allowed you to contribute $3 to the presidential nominating convention. And this fund had existed for a number of years. And what the bill that passed and was signed into law did was it transferred $126 million from this fund into a new pediatric research initiative fund. And it thirdly authorized Congress on an annual basis to appropriate $12.6 million a year to the NIH Common Fund to establish a pediatric research program. The first appropriation happened in 2015. So when NIH learned of this, this money coming our way, there were a number of high-level meetings that were held. As John alluded to, Dr. Gibbons was involved from the very inception of these discussions. And the vision that was put forth as a result of these initial discussions was to foster collaborative research on both childhood cancers and structural birth defects. And the idea behind this was to centralize access to large amounts of genomic and clinical data in a data resource. We figured this would facilitate collaborative research, it would accelerate gene discovery, and ultimately it would improve diagnostics and possibly therapeutics for these conditions. So to that end, the goal of our program is to establish the data resource and to populate it with high-quality data. As Dr. Gibbons mentioned, as is with all Common Fund programs, there's multi-institute leadership of the program. So we have Dr. Bianchi from NICHD, Dr. Brody from NHGRI, Dr. Gibbons from NHLBI, and Dr. Lowy from NCI overseeing the program. And we have a Kids First leadership team, which many of you have been interacting with over these past few years. We have program representation from the 4 institutes, and as we funded each of the major entities of the program, we brought on board additional program officers who are serving as project scientists on the cooperative agreements that we funded. And the glue that holds us all together is Valerie, who you all have been in contact with. She and I work pretty closely at NCI to coordinate the day-to-day running of the program. We also have a Common Fund trio of program staff that work with us, and I don't want to forget to mention the grants management specialists that oversee the administration of the grants that we award. These are run out of NCI and NHLBI. And very importantly, you need to know that there are 9 other NIH institutes that have program representation on the Kids First Working Group. So this is a pretty broadly supported program across NIH. We also have representation for the Office of Research Infrastructure Programs, which is part of the Office of the Director. And we also have an ex officio member from the CDC's Center for Birth Defects and Developmental Disabilities. So when the program was established in 2015 and got the green light to move forward to implementation, we came up with 3 major initiatives. The first of these is cohort identification and DNA sequencing, and this is where the EXO-1s come in. We also funded under this initiative the sequencing centers, and I'll talk about those in more detail in a second. The second initiative is the establishing the pediatric data resource, and this was just done this year, and I'll talk about that. And Adam Resnick will be speaking after me to actually provide many more details about that. The third initiative, which is a little bit in the future, is data analysis, both data mining and data demonstration projects. And as you'll see, this is a transition we've yet to make fully. It's to be implemented in the future. And I want to point out at this time that we're very open to input from the community on this aspect of the program. So if you have any feedback after these presentations this morning, we'd be happy to hear that from you. Okay, to get the ball rolling in 2015, I'll start first with the sequencing side of things. What we did initially when the first appropriation came through was to leverage existing large sequencing centers that the NHGRI was funding, and we awarded 2 administrative supplements through those grants to Baylor University and Washington University to stand up our sequencing pipeline in 2015. We also initiated a solicitation to the community, soliciting cohorts for sequencing, and we used the EXO-1 mechanism. Those of you that got these awards understand the process, but for many of you, this may be a different type of NIH grant mechanism. So I just want to point out that the EXO-1s are designed to allow the recipient access to an NIH resource. They don't actually award any funds to the investigator. So people that were awarded EXO-1s were granted access to the sequencing centers. So the appropriation in 2015 was awarded to the sequencing centers by NIH, and then we selected the EXO-1 recipients that were allowed access to the sequencing centers to have their cohorts sequenced. This gave us a little bit of time to then put a solicitation out on the street for our dedicated sequencing centers for the Kids First program, and we did that in 2016. And the Hudson Alpha Institute, and in collaboration with St. Jude's Children's Research Hospital, and also the Broad Institute of MIT and Harvard were the 2 recipients of those awards. So they were both granted awards in 2016 to become the Kids First Sequencing Centers, and these are 3-year grants. Okay, this graphic summarizes everything that we've done over the last 3 years, and pointer here. I'm going to step out here so I can actually point to the slide, unfortunately, on the right. So this basically summarizes the sequencing activity that over the 3 years. As I mentioned, in 2015, we were working with Baylor and Washington University. We received 17 Exo-1 applications in response to our solicitation, and in total, these 17 applications represented over 20,000 genomes that were proposed for sequencing. We were able to select 7 of these to put into our pipeline, which represented about 6,000 genomes going into the pipeline. And our entire appropriation that year, $12.6 million, went toward the sequencing effort. We actually selected 2 cancer cohorts and 5 birth defects cohorts that year. And I want to take a moment to point out to everyone something that isn't immediately clear with the sequencing program, and that is that we basically divided the funding for sequencing between the cancer cohorts and the birth defects cohorts relatively equally. Even though as I go through this, you're going to hear that we funded more birth defects cohorts than cancer cohorts. The reason behind this is that the cancer cohorts, especially those that contain tumor samples, require sequencing at much higher coverage, and it costs more. So we're getting, I guess, in a sense, more bang for our buck with the birth defects cohorts because they aren't quite as expensive to sequence. Okay, so in the second year of sequencing in 2016, we again had our solicitation for Exo-1 cohorts. Now we're working with the Broad and Hudson Alpha for sequencing. We got 15 applications representing in total over 12,000 genomes. We were able to select 8 to put into the pipeline, and in this case it was 3 cancer cohorts and 5 birth defects cohorts representing not quite 7,000 genomes. And again, in 2016, the entire $12.6 million appropriation was spent on sequencing. This year we had another solicitation, 15 applications received. Again, a very large number, almost 19,000 genomes were requested. Sequencing was requested for these. We selected 8 cohorts to put in the pipeline representing a little over 5,000 genomes. These 8 cohorts represent 2 cancer cohorts, 5 birth defects cohorts, and 1 very interesting cohort of children who were born with a structural birth defect and then later in life developed a pediatric cancer. So you'll notice here that the amount that went to sequencing this year was about $9.5 million. The reason it's a little less is because the other thing we did this year was to solicit applications for the data resource, and in July we funded CHOP as our recipient for the Data Resource Award. So about $3.1 million went toward funding CHOP. This is another way of looking at what we've done over the last 3 years from the sequencing perspective. We add everything up. We've had over 47 cohorts proposed for sequencing in our Exo-1 solicitation, representing over 52,000 genomes. We were only able to put about 18,000 of these genomes, representing 23 cohorts, into our pipeline, which leaves another 34-plus thousand genomes out there that we know could be sequenced and go into the data resource. So there's a lot left on the table. And I just want to put that out there because at the end of my presentation, it'll factor into our discussion about how the program proceeds in the out years. This list is an alphabetical sequence, the 23 cohorts that have gone into the pipeline. And to simplify things, I've simply indicated it's behind in parentheses the fiscal year pipeline that the cohort went into. And there's a couple of things to point out. There were several very large cohorts that were proposed for sequencing from the very beginning of the program. And because of the limitation of funding, we weren't able to focus on any one of these big cohorts. So we encouraged these applicants to reapply in subsequent years. So, for example, the congenital diaphragmatic hernia cohort has gone into the pipeline 3 times. This represents a cohort represents a cohort that that has been heavily supported. The research has been heavily supported by NICHD. And then there's the orofacial cleft cohort, which again is a program the Dental Institute put significant backing toward, and they have had different cohorts go through the pipeline. And finally, the Heart, Lung, and Blood Institute has a large program in pediatric congenital heart conditions, and this cohort, which was collected under their funding, has also gone through several times. And I mentioned the one interesting cohort here, which is the patients with who were born with a birth defect that developed a childhood cancer. We have some very interesting cohorts that are in the pipeline. So far, from 2015, only one of these cohorts, the congenital diaphragmatic hernia cohort, has made it through the pipeline, through QC, and out into the public domain for researchers to access through dbGaP. We have the rest of the 2015 cohorts coming through this fall and through the winter, and then the 2016 cohorts will be following shortly thereafter next year. So there is perhaps more of a lag than we realized there would be getting things out of the pipeline and QC'd and into the public domain, but you know, we're working that as fast as we can. Okay, so I'm switching gears just briefly to talk now about the data resource. I'm just going to give a brief overview here because Adam, as I mentioned, is going to talk in depth more about this after me. So it actually took NIH staff the better part of a year to figure out how we wanted to organize the data resource for this program and to talk with various entities across NIH about the best approach to take. We weren't about to start reinventing the wheel from scratch. We wanted to learn lessons from those that have tread this path before us. So when we put out the solicitation for these applications to develop the data resource, we decided that there should be three components to the data resource, and this made for a relatively complex grant mechanism. One of the things the legislation did was it prohibited us from actually issuing contracts. So we weren't able to develop this through a contract mechanism. We had to use a grant mechanism. So the three components for the data resource are the data resource portal, which is the outward-facing public platform. And then behind that is the Data Coordinating Center, which will deal with the sequencing centers and exo-1s and facilitate deposition of sequence data and phenotypic data into the appropriate repositories, and then the gargantuan task of harmonizing phenotypes and all the clinical data across the cohort. And last but not least, and importantly, is the admin and outreach core, which will do the typical things one of these cores does, but in our case, a very big component of this part of the program is outreach to the advocacy groups. And we are very cognizant of the role that the advocacy community has played in the initial establishment of this program and the fact that we are dependent upon your continued support for our annual appropriation every year from Congress. Okay, so CHOP has received this award, and I just want to point out the overall structure of their grant. It was a complex grant mechanism, and the program that they're standing up and running is very complex. So there's a team at CHOP under the direction of Adam Rusnick, and there are 5 subcontracts to the entities that are listed here: Seven Bridges, Ontario Institute for Cancer Research, the University of Chicago, which houses the BioNimbus Trusted Partnership with NIH, and Oregon Health Sciences University and Children's National Health System. And I also do want to point out that there are a number, over 24 at this point, commitment partners that have also pledged support to the development of the data resource that the CHOP team is going to be working with over the course of the development of the resource. And we're very pleased to see the outpouring of support that's come from both the academic, foundation, and corporate communities. So at this stage of the game, we have, as everybody before me has said, basically the four major components of the program up and functioning. The NIH working group has been there from day one. The XO1 investigators have been with us now for 3 years. We've added more each year, and we will continue to do so next year. The Data Resource Center, the sequencing centers have also been with us, and the Data Resource Center is the most recent to come on board. So during the course of this meeting, we're going to be standing up the steering committee, although we don't plan to have a formal meeting, because the one thing that NIH still needs to do is to put in place a chair for the steering committee meeting, and we haven't done that yet. NIH is also talking with experts to serve as external scientific advisors for the program, and that process is underway but not yet in place. Before I go to my last slide to summarize things, I do want to point out that we have put in place through a separate funding source, not through the Kids First appropriation, but through the Institute's normal appropriation process, a mechanism for funding data analysis at these early stages of the program. And this is the small research grants for analysis of Kids First data using the R03 mechanism. This was initiated by NICHD, and there are 5 other Kids First participating institutes that are part of this funding opportunity announcement. And we're accepting applications through this process for R03s on the standard receipt dates. And there's a combined budget of $200,000 direct costs over 2 years being offered for these grants. This is a way for the XO1s in particular to get funding to do data analysis, since we're very cognizant of the fact that as XO1s you don't receive any direct grant support through the XO1. And I'm happy to say we funded several of these applications and with more in the pipeline. And there is another route in place for actually receiving support, and this is through the investigator-initiated R01. And any of you can submit R01 applications for data analysis, and these applications get assigned to whatever institute is best suited based on the science proposed. And we already have one of the XO1 investigators who's received one of these R01s, and we have another one in the review pipeline right now. So we're hopeful that people will make use of both this R03, which is out there for 3 years, and also the R01, investigator-initiated R01 route for getting support for Kids First data analysis. So where we're at right now, and this is just to summarize everything I've said and to tell you where we're headed, the program is mandated for 10 years. From 2015 through 2024, and right now our Kids First budget is a $12.6 million appropriation each year, and as I said, we are dependent upon the annual appropriation process through Congress to get these funds, so it's not an automatic transfer of funds each year. As I said, the first 2 years, the entire $12.6 million appropriation was devoted to sequencing through the XO1 mechanism and through the sequencing centers that were supported initially by the administrative supplement, and then the U24 that were awarded to Hudson Alpha, St. Jude's, and to the Broad. This year in 2017, we split the funds because we also funded the Data Resource Center through the UTC mechanism, and this is at $3.1 million, which is left about $9.5 million for sequencing. According to our plan that was established at the inception of the program in 2015, we're slated to start data mining and data demonstration projects actually in 2020. But this is up for discussion, and it's something that the NIH Kids First Working Group has been actively discussing with our IC Director co-chairs. And I just gave a presentation last Friday to Francis Collins Council of Councils, where we also sought input from those advisors, because we're debating about how to make this transition from sequencing to data mining. So one of the options that was put forward was to extend sequencing for another year, because right now the sequencing centers are funded from 2016 to 2018. 2018. We could extend this for another year, or we could extend it even further and delay the implementation of the data mining and simply rely on the existing programs that are in place, the investigator-initiated R01s and the R03, which is indicated here outside the normal funding stream for Kids First. This is a 3-year program that can also be extended for an additional 3 years. We also can kind of ramp down the sequencing as we ramp up the data mining. So these are all things that are on the table right now. We're seeking input from you during the course of this meeting. So if you have anything you'd like to tell us, we're certainly here to listen. And I think I'll wrap up at that point. We're not going to have discussion right now. We're going to go ahead and let Adam present his talk on the Data Resource Center and the vision for that part of the program, and then we'll open the floor for discussion after that. Yes.
Good morning, everyone. I always worry about rooms that are set up in this fashion because I worry they end up being a little too serious for the kind of discussion that we want to engage. But I was talking to Ellen just before we started, and there's this interesting tension, right, between the seriousness of the objectives that we are undertaking, but at the same time, a true thrill and excitement about really having come together around this. We just had our technical meeting a couple weeks ago, and in the technical meeting, I positioned all the pieces coming together in the context of the A team, right? The NIH ended up being Mr. T's truck at that presentation. But I think we're closer now, maybe to those of you who watch Transformers, right? There's always this element where all the different Transformers come together to a super Ultron sort of Transformer that can essentially do more than each of them individually can. And really that's the theme, I think, behind much of what we'll be discussing today. For my talk specifically here, I just wanted to set the tone because, as was mentioned, we really assembled a very diverse team who will dig more deeply into each of the elements of the Data Resource Center. And for us, I just want to pause momentarily because, we came in only very recently into the Kids First program. But for the light, right, the NIH team and the EXO1 teams and the sequencing centers have been an amazing group of people to come into synchrony with. And as was mentioned by Malcolm, it's going to be challenging. So despite our elation, we know it's going to be hard work, but I think we have an amazing team together to do it. I thought I would contextualize because I think sometimes it's worthwhile to think about this, or the why, who, what you do. I was both an English major and a neuroscience major in college, so there's always a structure to the storyline of the why, who, what is in the story. And I wanted to capture that moment for us as we move forward in our vision. And I wanted to do it in a specific context. It was almost to the day a year ago that many of us in this room were actually at the proclamation at the White House for Childhood Cancer Awareness Month. Chloe was there, and there was a moment of recognition that cancer was at the forefront of people's minds. Not that it wasn't, but the Cancer Moonshot was taking place, and really there were many childhood cancer foundations and families there. And since that year, so much has happened in ways that I think position us to move forward in a dramatically new fashion. And despite the focus on Childhood Cancer Awareness Month, what the Kids First program does actually is break down the barrier, even around childhood cancer, to bring in additional partners, which I think we can demonstrate is necessary. Now, because of Childhood Cancer Awareness Month, every single foundation has their website dedicated to this context. And it's worthwhile just taking a moment to understand the urgency that people feel around moving forward in this effort. And And I think that's something that Ella and I were talking just right before we started, and that is there's a time quotient that is constantly at our backs. And that's because, in the context of cancer, time is the only part that we cannot reverse for these children. And I think that's the space that we're all under tremendous respect in the context of working with the advocacy groups here. And so I'll just go through a couple of these notation, which every single foundation knows and knows well and repeats on a daily basis, because it's what keeps us up at night. And I think we can assure everybody here that we'll be up many nights over the coming years, essentially, as we do this. And the fact that 7 children will lose their battle to cancer today, right, means that as we sit here today in this conference room, there's a certain gravity at the same time as we move forward. Importantly, and I think this is what the genius behind the Kids First initiative, and it's one of the things that we face as a challenge consistently when we, as researchers, try to establish a pediatric enterprise for cancer, and that is that cancer in kids is different. Kids don't smoke, they don't stay out in the sun too long, and that it's really the developmental biology paradigm that drives the pediatric cancer landscape, and that is fully recognized for the first time in the context of this grant in ways that it hasn't been before. And so when we think of Kids First, there's a couple of meanings for that, right? One is positioning kids first, but the reality is, and I'll try to point this out throughout the day and now, we're actually going to be doing many firsts. And that means that we'll have some failures, but many successes in doing these first things for the very first time. The other thing that almost every single foundation here has is something along this line that really challenges the funding mechanisms around the pediatric enterprise. And again, this is a first, right, that really highlights the differential and focus that we move forward. Now, I was going to actually use this example for how we think about cancer and have been thinking about cancer and the opportunity before us. And so Gabriella and many of the foundations and their children here actually succumbed to a disease called diffuse intrinsic pontine glioma. And we'll just use this as an example for both the failure and opportunity that we as investigators have had to carry. And I've given this example in many different contexts, but I think it's worthwhile repeating for the rest of us here. So DAPG is essentially a disease that from diagnosis to the time a child succumbs to disease is really only 9 months. So immediately when you're dealing with a 9-month spectrum, right, you have to start thinking about time. And if we really believe, right, that data has the power to provide answers to a cure, right, time is a quotient around data that connects to the data sharing, that connects to its availability, unless you're sufficiently narcissistic to think that you're the only one who can essentially make discoveries in really complex data. So for us, from the very beginning, even 6 months, which is still the currently established timeline for genomic data sharing, that's 75% of a DAPG patient's lifespan, which means that the time differential we have to think about really has to align with the technologies that we'll be implementing in the context of the Data Resource Center. Everything we'll be doing in the Data Resource Center will be geared towards time. Acceleration of discovery from access to its distribution, to its analysis, to its integration. Everything is going to have a time quotient as a metric for it. What does it have to do with structural birth defects, and how can the model be completely overturned? So DAPGs, for a long time, have been very challenging, in large part because they occur in the ponds of patients in ways that surgeons have no way to tackle. And as a result, we have very limited information about the underpinnings for DAPGs, but the number of phenomenal groups, some of them were part of the EXO-1 themselves and the sequencing centers, somewhere between 2011 and 2012, did some phenomenal work to discover entirely new mechanisms of how DAPGs and cancer actually operates, establishing oncohistones as a primary mechanism. And this really defined new mechanisms or ways around which mutations drove epigenetic dysregulation in cancer, did not necessarily provide an immediate route for therapeutic implementation, but defined new understandings of the development context of cancer. A few years later, it was recognized that 1/5 of all DAPG patients had another mutation. This mutation, however, is one that was known before. And one of the challenges when I always tell this story is one of personal failure in this context, and it's worthwhile noting. And that's because of all the groups that should have been able to immediately understand and not wait 3 years. Right? Remember, 3 years is a large number of lives in the DIPG landscape. It should have been us at CHOP. And specifically, it should have been actually in my own laboratory because we were sequencing a few DIPGs at the time, very soon after the histone mutations were discovered. And the reason the failure occurred in many ways, and that failure relates to a delay in starting clinical trials because ACVR1 actually has potential therapeutic intervention. The reason that the failure is so poignant is because when I first moved to CHOP, the building where I was going to actually have my laboratory was not yet built. So Penn actually accommodated me for the first couple of years on the 5th floor of Sterno building in the medical school. On the 4th floor of the Sterno building is the laboratory of Fred Kaplan. And Fred Kaplan essentially is the FOP investigator across Europe. Fred actually knows all 882 patients that have FOP. In 2006, he discovered the ACVR1 mutation that underpins FOP. That's the exact same mutation that is found in DIPGs. What does that mean? It means that in my late night meanderings, as I was walking down the hallway on one floor below us, and I interacted with Fred and others, I should have immediately had in my head potentially, right, that R506H mutation in ACVR1 is a meaningful mutation. But even as we were sequencing DIPGs at the time, with Fred Kaplan right below me, right, he could have, might as well have just been in Timbuktu, right, because there was no data architecture that allowed for automatic assembly and understanding between a rare disease that causes bone deformities, and kids are born with essentially deformed big toes, and brain tumors. Right? There was no data architecture that allowed for those two things to intersect, right, that would automatically just spit up and say, hey, this rare disease, right, already since 2006 has known understanding around what the biology of this mutation is there. And so we had to wait, right, from 2012 to all the way to 2015 to initiate the clinical trials. 3 years, 9 months median survival time, that's impactful in ways that is now our mandate of the Data Resource Center to never recur, right? And that's really what drives the way we think about it. This intersection between rare diseases and cancer in the context of development of biology, where no matter how dedicated a researcher you are, unless you have the right tools, right, in the context of access and utility of data, you will fail. And we have demonstration of that in that context. So for us, you know, that's never going to happen, at least not under our tenure for the Data Resource Center. The next question is the who that's going to be doing this. Some of this was discussed, but again, for us, right, engaging such a diverse landscape of NIH stakeholders ensure sustainability and support in ways that are unprecedented. Right? There is a reassurance around the dedication at the level never before seen for us in our community. Along with the sequencing centers that are doing the work, as Lorette mentioned, we actually have several commercial vendors who are stepping up and making commitments for additional sequencing data generation. And again, we'll work with you and the NIH to identify which cohorts, in addition to the funding mechanisms provided by the NIH, should be used in the context of these. The other part is, you know, we have all the EXO-1 investigators. This is the first time for us at the Data Resource Center, right, that we are actually in proximity in the same room with the EXO-1 investigators. You know, when I began looking at all the different institutions around them, it's actually fairly impressive, right? And all of us who are in academia, you know, as Malcolm mentioned, you know, collaboration is partly in our DNA. Collaboration, no matter what, is hard. You know, it's a challenging environment to collaborate in the context of really competitive science and high-level science. And in many ways, when the EXO-1 investigators actually submit their samples up front, right, they are essentially assuming a level of collaboration that, again, is almost unheard of in many of the types of efforts that we've been involved in. Similarly, big data efforts like AWS, Sage, and Google have also made commitments. And at the same time, how that data should be best made available, right, through publication and others, additional community members like data science, and nature are going to come on board. This is just a few of them. So some of the structure has been defined, and it was a challenging grant to put together, but in many ways, it was really prescient of the NIH to define the necessary components of the Data Resource Center in ways that if any of the elements would have been missing, right, I think would have been doomed to fail. And so for us, it was key to actually engage it. And in many ways, we were very fortunate at CHOP to engage really phenomenal partners who have been in the business of supporting large-scale genomics across multiple fronts. And the cool part, when we began engaging the OICR, University of Chicago, Thurman Bridges, OHSU, and Toulouse National, is that none of them wanted to do what they've already done. They already know how to do what they've done. They all want to do something completely different at another level. And so this is not a grant or a mechanism that's bringing pediatrics up to parity with adults. This is a mechanism that's doing something different and potentially something that the adults could not do, right, in the context of really bringing together a very diverse landscape of research. We talked about the organ-specific approach, and the organ-specific approach is likely going to be retained in the adult space a lot longer than in the pediatric space. And that means that we'll have to do things very differently to support this, and it will be challenging to harmonize across those efforts. For us, one of the RFA's requirements was a data resource portal. And like I said, our group has built data resource portals. But if you look at the definition of what a portal really is, right, a portal is really the gate, right, or the entrance from one place to another, right? And that's not what we want to build, right? We don't want to build a thoroughfare to somewhere. We want people to come as a destination to the environment to do their efforts. And so for us, we're actually building a user resource portal, and that's a distinction, right? The hope is that if we're successful as a data resource center, is that it's not an environment you go through, it's a destination for you to do your research, right? Research at the level that will be necessary, at the level of the data, right, that's being generated, will have to occur in an environment that is non-local, right? And that means that there has to be a destination for that non-locality. And these are things that have continuously emerged as we've worked with the NIH, even most recently, in ways that I think have been inspiring because the NIH and the team members have been willing to continuously iterate on the idea of what it's going to take to actually support discovery in ways that align with a 9-month median survival time. Today, you'll see each of the groups present where they've been, what their successes have been, and then for the next 2 days, each of them is going to present, each of the teams is going to present their vision for the future and what they're going to build. Right? So they're going to essentially present to you their expertise, what they've done, how it is that they've arrived at this team in the context of the Data Resource Center, and then take the next step to orient towards the future. And importantly, that orientation to the future is not a self-informed act. What I mean by that is it's going to require participation. Right? Another failure for us will be that we build what we think is an amazing portal that is not an amazing portal for the user. And the user space for us, as I mentioned, is very diverse. All right? And that means that there will be a high level of engagement and hopefully less quiet as everybody sits around and listens to this effort. And we'll have some activities to support this. And we've already been engaged in some surveys, and I wanted to really appreciate your participation in those surveys. And we'll define by the end of the 2-day session really the vision, the immediate vision of how it is that we're going to empower immediacy around use of data with new architecture and the Data Resource Center's current resources and existing architectures. The last piece, which I think Laura highlighted importantly, but in many ways, and this is not to demote the NIH, but the true assessor of our success is going to be the foundation. A year ago, at the proclamation for the Childhood Cancer Awareness Month, I watched Doug Lowy, right, navigate a very challenging audience, right, who essentially was probably more challenging than any of his superiors had been in the past, as patient after patient family asked them what is going to happen next, right? And in many ways, we see our foundation partners, which many of them are here, as both our greatest stakeholders, but also our biggest stick, right? They are the most highly advocate, data empowered you would find. They are the most highly advocate, collaboration motivated entities you will find, and those are the ones that will have to most ensure that we do not fail. So how do we do that? And I was trying to think of how to end this first session as a demonstration of the potential. And I don't know if this is going to work, but I essentially created two graphs, two networks, essentially. And I think everybody's still too quiet, and I'm hesitant to sort of ask for a show of hands, so because I risk lack of participation. But one of these, right, is the protein interaction network in a particular cancer, right? The other one is the unknown. And the other one highlights the true potential in ways that I think even the audience here is not fully aware. So what I did late last night is essentially collected all the Exo-1 investigators' publication records, right, and all of their authorship affiliations with every single one of their publications. Then created a network around all of those. And so these are all Exo-1 investigators across very different fields, right, who essentially, some of them have collaborated in the past directly, but most of them have not, right? And there aren't that many yet, right? There are only maybe 13 or a handful of them right now. But all it takes is to take all the authorship lists from each one of those 13 members, intersect them by who potentially has co-authored a paper with somebody else, and they're immediately completely connected, right? Immediately, every single Exo-1 investigator is connected to every single other Exo-1 investigator simply by the body of work that's done through collaborations that they may not even be aware of. What that means is that unless they're doing shoddy science, right, that those papers actually are connected scientifically, right? So latent in their collaboration, right, and in their scientific productivity is a potential for discovery in ways that I think we'll find out over the next several years to truly empower this. And it's there. It's in the data, right? We just don't know it yet. So I'll stop here and really, for us, even doing the work of the Data Resource Center is going to be a collaboration. We have an amazing team who are true experts, but none of them, I can say, are narcissistic enough to think they know it all. So please ask questions, interact, challenge us, critique us. We have a very low, small ego, at least at this point in time, so you can critique us as much as you can. I wanted to pause briefly and just as we go through the agenda and really thank both the Data Resource Center outreach team and the NIH for really putting together an amazing agenda in a very short amount of time. They're all saying it's very cool, but it wasn't so trivial for actually a very short amount of time to put it all together. And I wanted to pause here to really provide an opportunity for us to ask some questions about where we are as a group. And more specifically, we already put some questions out into the audience space and the foundations who are here around this. And I think these questions that we received back are ones we're going to continue to hear. And it's going to be a narrative that we have to define for the community. What is it that we're doing differently, right? Why is it timely to do it now, and what are the real opportunities? So we'll pause here momentarily, and I think some of you already know the get questions that are going to step up to ask questions, I think, right? Am I in the right space? Yep. I'm going to go from there. Anybody can ask questions, though. It doesn't have to be foundations. It can actually be anybody.
So there are a few microphones around the room. There's one right here. There's one in that space. I'll come make sure they're turned. I have one here too. Yeah, okay, can I pull the mic back? Yeah.
So maybe I should ask first, is anybody surprised by the existing collaboration network among investigators, or everybody already knew that?
Which one is which?
What's that?
Can you say which one is which?
I didn't reveal that there. So every network has hubs that are bigger than others, right? And so this is where, if you do want to soak your ego, right, you can do this experiment yourself, right? And you can assess your own hubbiness within the network. Because some of you, XO1 investigators, are more critical to the network integrity than others, but all are required for the connectivity to function.
Who's the Kevin Bacon, I guess?
That's right, exactly right. That's right. It's exactly like that, right? And actually, it turns out that Kevin Bacon is actually not the most connected actor. He's probably actor number 582 on the list of actors. It's actually some of these older, like 1940s actors who have had more longer career. That's exactly like that.
Okay, I'm Amanda Haddock with the Dragon Master Foundation, and I had a big list of questions that Adam's actually covered a lot of them. So one of my questions is, who will be able to access the data in the Kids First Data Resource Center, and what kind of approval process will they need to have in order to access the data?
Now, I'm prohibited from answering every single question. So I think somebody else is going to actually have to answer that question.
Okay, so people are pointing to me. So these data were collected under consent that the patients signed at the time they entered studies and gave their samples for research purposes. And depending on the data use limitations that were put in place by those consents, that will determine who actually can get access to the data. So whether the data ends up in the existing NIH NCBI DBGAP repository, or whether it ends up through the Trusted Partnership in the Kids First Data Resource, researchers who want to use the data will have to apply for access, and they will have to meet the requirements that were established by the data use limitations. We have to respect the consents that were used to collect the samples.
Sure. So can I ask a follow-up?
Sure.
So moving forward, is there going to be an effort to make that more open access?
With samples that were already collected and consented, we can't change those data use limitations. But ever since the inception of this program, one of the things NIH has been preaching to people in the research community is the need to have most general use limitations, lack of limitations put on their data that they're collecting. And so there is this effort to have consent language that allows general research use that would facilitate broad sharing of the data through the data resource.
So preaching it is great, but what kind of team? I mean, are they actually going to say, no, you're not going to get funding unless you're sharing it more broadly, or is it still kind of up to the researcher?
Well, it's a process, and we have made it very clear in our funding opportunity announcements that have solicited the XO1 that the program reserves the right to pick cohorts to go into the pipeline that offer the broadest sharing. To be honest, we don't want to rule out some of the cohorts that we receive for sequencing because they're very valuable cohorts. And even though they come with some data use limitations, we have put them into the pipeline. I think going forward, especially as we extend the sequencing effort, the community is aware of this, that we can do this. We have the right to do this. And I think it will become more of a factor in future years because right now we know there are investigators that are soliciting and consenting people with the idea that they're going to apply to the Kids First program. So we're hoping that these more prospective cohorts that are being collected now and that would come in later years in the program will have more general use and we'll be able to transition to that.
One thing to add, and this is at the Data Resource Center, by and large, investigators recognize, that there's an element of fulfilling, right, their promise to the patients from which to get the samples, right, to empower that data maximally. And so one of the things, and you'll see some of these highlighted in the talks today and even some of the efforts tomorrow, that, the conceptions around data sharing are maturing and evolving. Technologies that empower oversight and governance over how data is used, visibility and transparency around that, can actually empower data sharing even in the context of limitations because in cloud-based environment where you can control who and what happens to data, who's touching it, at what point in time, if they did something wrong or not wrong to that data. Those are the kind of tools that will be implemented in the context of the DRC that will support even the more restrictive environment for maximum use of that data. Because I think up until now, much of the time when people had access to data, they were really just downloading it, right, and taking it home, right, with it. And on that space, there are sort of concerns that emerge, right? You know, how strictly are people following the rules? But within new tools that will be emerging in the DRC, will have greater capacity for complete transparency around who did what and when and how.
Along that line, two questions. I thought that we were able to read consent if we wish. It's extremely difficult, but you can go back and for someone who has a restricted consent and then eventually change it in both in any database. But the other question I have, you know, it just occurred to me, we're under a restriction, and I think it's NIH imposed, that minors must be reconsented as adults at age 18 to remain in study. And it just occurred to me, what are we doing about that relative to data? And is that actually a policy, or is that just busting children? I'm unaware of an NIH policy in that regard. It might be something that it's IRB based, but it is actually something that occurred to me that we do have. For example, my IRB requires reconsent for adults, and I think others do. Okay? So it's something we should just think about. Yep. Yeah. Yeah. I mean, we just to get back to Amanda's original question, one of the things we did in June was to bring the XO1 investigators together for a collaborative workshop, and we did go through in pretty great detail the data use limitation process, because it really is derived directly from the consent forms. But in many cases, the way the forms are filled out, when the investigators and the IRBs submit these forms, they're check boxes, and the tendency is to check everything I would like to have in place and not actually relate it back to the original consent. So we have encouraged investigators to go back and look at their consent and to update their data use limitations if they could be more general. So that's a process we've started too.
But to your point about the consenting past 18, this is something that at least we and many of our efforts have encountered as a differential implementation across IRBs. And I think many IRBs are always open, right, for new engagements of dialogue. And here maybe we have enough, right, high caliber scientists who potentially can highlight, right, the differentials amongst IRBs for what it is that you are currently doing. And I think there's ways that, you know, through transparency, gating the conversation in the context of the kids first, right, we can actually drive some policy. And that's one of the challenges we face in many of our consortium-based initiatives is, right, the high degree of variability across IRBs for their interpretation and implementation in that sense.
I have a question about data redundancy and storage versus computational cost. So a lot of us are maintaining these data on institutional servers. They also, the data resides, eventually will shortly reside in the gap. And now it sounds like they'll reside here as well. And obviously there's considerable cost associated with each of those. And I'm curious how you see this as being something that allows for computational interaction without having to download, as you were just saying, everything and do it locally.
Yeah, this is something we spent an immense amount of time on thinking about even in advance of the Kids First initiative, and more specifically the last month working with the NIH more intensely. And there are a couple of different narratives that I think is important to note. One, people download data locally largely because institutions subsidize, to a larger extent, costs around their own data centers. But that is, as you said, a really limiting environment for collaborative discovery or data integration and management. Some environments are terrific at that, but even those leading edge environments have moved into cloud-based architecture for that. We had done an assessment where we scraped So the NIH, the PDGAP actually publishes, right, who got access to what data, right, and for what purpose. We scraped PDGAP to assess the number of times a certain data set was downloaded and by whom. Even within our own institution, the same exact data set was downloaded multiple times. Some of the largest data sets, GCGA, like multiple times, right? In ways that under NIH policy, you could actually establish with a double click a collaboration within your own institution under the same institutional officer. So currently there, like you said, even within the institution, there's a great duplication of effort oftentimes around data storage. And so the narrative around cost basis that can be offset in a common cloud environment where there's only a single copy of that data, right, and potentially a copy of record somewhere else, but that data can be pointed to and utilized in the cloud environment. That's going to be the model that the common fund, the data commons, the genomic data commons for the NCI, many of these spaces are going to move forward. And you'll hear a lot more about that over the next couple of days, essentially. We're still, again, it's going to be a first, right, in the context of what we're doing here. But it's really the only sustainable model with a large amount of data that we have in ways that will be respectful, right, of both the amount of money that was spent generating that data and its utility. So cloud-based environments, I think, are going to be the norm, right? And how those are governed and managed and accessibility provided, we'll discuss in great detail over the next couple of days. Currently still under the NIH policies of PDGAP access management. Does that make sense?
Well, no, I get all of that. I don't quite understand some of the nuances for the following reason. As wonderful as Gabriel Miller's his first program is, there are other sources of getting genomic sequences, and sometimes portions of a cohort will have been sequenced through this mechanism versus another. Yet the analysis, as you know, wants to be a single analysis. And so if it's going to only contain a portion of your data,
that's exactly right.
You've got to download it to run the analysis, which is where I think.
Or you're bringing your data into
right.
that.
So that then begs the question of cost. So
the Common Fund folks said that their cost is not
you get the money.
No, I think that this is, again, a true mandate for us within the Kids First program, right? There's a tremendous amount of funding being spent on new data generation, and one of the things we have to do is demonstrate that intersecting very diverse data provides new solutions. But a second role for the Data Resource Center is to provide opportunities for intersecting X01 data, right, with non-X01 data, right, and demonstrating that there's utility and value in doing that. There are a number of programmatic initiatives within the NIH itself, and there are different mechanisms that are perfectly fit for that. But the real long-term solution is probably going to be, like you suggested, where investigators themselves have to do it. Now, there are a number of different ways that, and different opinions, right? And I see Danielle raising her hand in the back because she's always very conservative, right, about this. And we need both conservative and open views around this. But the reality is that in the data generators themselves are no, in the next couple of years, they're not going to be, right, the common funds, right? Within the next few years, it's going to be a lot different. Go ahead, Danielle.
Well, I just would like to make sure that people understand that the plans and the FAST-Q files were not actually meant to reside in this data portal. That what you are, and it hasn't been quite, I think, stated clearly, the bands and the FAST-Qs are going to be for cancer at the GDC, for the congenital defects are going to be wherever the decision is going to be made. You are not going to be housing necessarily the raw data.
Yeah,
and that hasn't been quite, I think.
I think this is the thing we'll have to discuss over the next couple of days. The BSTEM mandate of having access to the raw data for the exact reason you suggested, right? Harmonizing the data for interpretation and value. It's an ongoing discussion on the ultimate storage, location, funding mechanism around that, and I think the NIH itself is struggling with that question.
I just want to make these are great questions, and I think that a lot of details are going to come
Yeah.
up. We have a couple of foundations
Sure.
that were queued up to ask the questions during this period, if that's okay.
way to get people to talk about something is to mention money, by the way.
Hi, I'm Jimmy Cronstead with the Swifty Foundation, and as Adam alluded to, we have a very strong, motivated group of foundations supporting this initiative. And we would like to know, in addition to funding and dollars, what else can we do to support the researchers, both collaboratively and independently?
One of the things is if you can start educating the patients about this consent process, if we are trying to make the data as accessible as possible, the patient is the main player in this game, because he's the one who will authorize or not the data to be accessible and how the data will be accessible and who can access the data. So if the patients are familiar with this process, it would be much easier for us. I think this is one big problem that everybody who's collecting samples has, is to talk to the patients about it. They are always like, what do you mean making my data accessible? Is it identifiable? Who is going to access it? And he goes, my question was, what is the ideal openness that we are looking for? What kind of files do we want to make accessible? And how we want to make accessible, but to whom also? We want to make every file, BIM file, DCM file, and other file accessible to anybody who wants to get the data from the portal. What's our limit? What we are looking for? These are the things that I think we should know, so we can consent the patient in the right way.
Yeah. Just to add on top of that, just briefly, one of the things that I think there's tremendous room, right, for patients' advocacy to encourage, and this was came clearly out of the Cancer Moonshot and in the 21st Century Cures Act, which was that there's tremendous actually authority for patients around their own data. Patients actually own their data in ways that are unique, especially their clinical data, right? And more genomic data and deep phenotypic data is going to be clinical in ways that really belong to the patients before it belongs to anybody else, actually. And that's, again, an entirely new domain that can be empowered in a very different way if we try to think of it in that manner.
So, one way to be controversial is to mention money. The other way to be controversial is to mention bioinformatics. So, I'm going to be mentioning bioinformatics. People say data science is the new oil. I'm going to say here, bioinformatics is the new oil to make discoveries here at scale. I'll simplify and irritate everyone in the room. By and large, most organizations, NIH is relatively conservative in how they do innovation in this space. And the role of foundations is absolutely essential, and most of them aren't involved in this. So just very, very simply, if you have to do innovation, you can get money from NSF in some spaces, but they won't implement. NIH is very good at implementation, but there's almost no money out there, and it only takes a small amount. In our experience, was a very small amount from foundations can go a long way to innovating in these bioinformatics areas in which you need innovation, but the by and large organizations out there are quite conservative. So in terms of multipliers, I think you could go a long way in terms of having an impact in some of these new areas.
Yeah, I just want to pick up on that theme of multipliers. So we talked a little bit about the RO3 mechanism to fund some of the analysis, and that's great. I'm one of the PIs for these awards, and it's a phenomenal mechanism to be able to sequence thousands of genomes, but we have not a single dollar to actually pay for the analysis. And of course, the RO3 is competitive, so not everyone gets that. So how can foundations really move things forward? Well, in my mind, the bottleneck as a PI is actually paying for the people to actually do the biomedical informatics. So I don't know if the foundations can offer separate grants or go into a bigger pool to help actually pay to analyze all this amazing data we're generating.
So I'm not. CETO with the Pediatric Brain Tumor Foundation, where the advocates for research but also have dollars, and they give us about $2 million for research. And so my question is around, we see our role as catalysts and trying to be innovative and trying to complement what the government might be spending and how we can do with the private dollars that we raise. To do that effectively, we have to get really savvy and understand the landscape. So part of what we'll get in the next 2 days. So our overarching question would be, and this would be for discussion over the next couple of years, I guess, is when we're crafting our RFPs or getting proposals into us that mention we're using this data resource or contributing to that. For us to craft the best RFP, how can we have real-time knowledge of what projects are getting funded or done that use the data resource? I was going to say it might be particularly interested in projects that are around gaining biological insights, but we actually understand the value of focusing on the computational methods that need to be developed. So we're not ruling that out as well. But how can we get savvy and aware in real time? Time is our enemy when we issue our RFP. One question. And it'd be great to have a list of the publications, just a simple way to go on the website and see what publications have come out of this work and we just us get smart.
Yeah, so I think I can probably help field this. I mean, I think one of the things we'd like to do with the data resource portal is have it not only for PIs and bioinformatics, but also for advocates and patients, so that you could see like all the projects that currently exist, what the progress is made, and profiles on the researchers, their interests, publications, etc.
Right. It's supposed to be part of this discussion in formal and informal ways.
And I'll just add one point to that, which I think is also begs the question that I think is sometimes challenging, which is the way attribution is granted to data sets, pipelines, its use. Currently, there's only one mechanism, which is sort of last authorship on a paper. That is not a robust mechanism for tracking the use of data. And so that's actually one of the things that is in the strategic planning for the Data Resource Center. And again, working in alignment with, I think, an ongoing discussions around the commons, the Data Commons initiative. And that is, how do you assign attribution at the level of the Amazon book selling, right? Who gets 3 stars, 2 stars, right? To much smaller components of the scientific process, especially around data, because you can actually metasite sharing in that context.
So I just wanted to respond to the question of what else advocacy groups could do to help researchers. One of the things I think a lot of us have learned is that we discover something that was unexpected and might not be related to the consent for which a family agreed to participate in a research study. And some of those findings are medically meaningful, and we as a community have struggled about whether that information should not be returned or should be returned. And I often feel, and our community has felt, that we're doing it in a vacuum rather than getting input from the people who could really weigh in knowledgeably about that subject. And I think that this kind of collection of science is going to accelerate those unanticipated discoveries that for the individual could be profound. And I think we need to really think about that. And mental health is critical.
Sorry, I'm not a doctor. I'm a parent whose son died 4.5 months ago from COPD. And I want to ask one question about Congress and one question about parent advocacy. So on the parent side, when we're approached by doctors about giving our consent forms and everything else, we're usually sort of shell-shocked and traumatized and relying upon our doctors to give us suggestions as to what kind of data we should release and to whom. I imagine that parent advocates would agree with me in saying that we have no idea how to answer these questions, and so to the extent that the research community can develop protocols protocols to help guide parents who are usually half a step away from, jumping off a bridge of heads of what's going on. We have no idea how to interpret what you guys want in terms of patient consent, because we're normally dealing with 20 bigger fish to fry. And my sense is that we're relying mostly on a single relationship with our doctor to give us guidance as to what kind of data we should be releasing to whom. And then we're, if we can see anything because we're blinded by grief and everything, we're just like checking boxes and signing forms without having any idea of what we're doing. So one thing on the patient side is to think about ways of developing more uniform protocols for getting consent from parents and patients who don't understand what the hell is being done with the data until usually our child has died or something has happened and we have time to sit back and marinate in sort of a lot of information that's coming at us. The second part of the question, I'm going to be meeting with my congressperson in a week to talk to him about increasing possibilities for increasing funding for childhood cancers. And I'm wondering, a lot of you I hear talking about, I hear a lot of you talking about the need for little tiny bits of money that can go a long way, and that there are these little sort of bottlenecks and everything else. And I'm wondering, maybe some of you could come talk to me in the coffee break. What are some of the things that parent advocates and others who are meeting with elected officials can ask for that would be meaningful, given the small amounts of money that are actually being devoted by Congress to researching childhood cancers, especially cancers like DAPG, which get almost no money for research.
Follow up with that, actually, that was one of my comments. As a researcher, it was great to work with the foundation on building, it's not a universal consent, encouraging foundations to educate their members on expanding the consent. Because it's great to have a narrow set of donated information about whether the child has had a previous birth defect or whether or not there were any birth defects in the family. But in order to do this research, it's helpful to have more expanded information that sometimes the researcher can't get from this particular consent. And it would be great if the foundations were aware that in order to help this research along, what often helps is more information per patient, as well as death, as well as the genome itself.
But to your point, I think there's a tremendous element of non-paternalism that we have to engage, right? And that's a space for the foundation that can be anonymous in supporting that narrative. Much better if a foundation is advocating for data sharing in a certain way than a researcher or anybody else.
Right. I want to sort of continue this theme because I think that the concept of openness and sharing is critically important for the success of this effort, and frankly all efforts, across the range of human disease. To me, so I recently changed institutions, and what I learned by virtue of doing so is how different institution to institution security considerations are, access to data, openness to using the cloud, not just for analysis, but for data transfer. I mean, it's really a bottleneck. And, an area I think that would be incredibly useful, both in terms of the data port, the data resource center, and also the advocacy groups that would cost nothing, basically, would be to advocate for open access for the use of cloud computing, obviously within the guidelines of consent, but just for institutions to harmonize across, academia to allow researchers to actually access data. I mean, frankly, I'm finding that, the different institutions get in the way of actually using data that emerges from grants because of security considerations that are outmoded. And so if the research, if the data resource and the advocates could say enough is enough, we need to make these data available and protected, of course, but available. Let's not think about this in the 1990s mode, but in a way that actually lets us leverage data that we've collected across the groups of investigators that are in this room and elsewhere. That would be a huge plus.
And again, as a data resource center, we see ourselves as the sandbox, right, for really evaluating some of these efforts, again, in allegiance with accelerated discovery, right, as aligned with patient consent. And the NIH crew has been fantastic, essentially, in assessing this. I think what you're saying is something we all recognize. And like I said, everybody wants cures faster, right? So any bottleneck is going to be a problem.
If I could just say that the Pediatric Brain Tumor Foundation, it's rare disease, 4,600 or so diagnosis under the age of 19. We aim to reach every single family at diagnosis. The reality is we don't. We struggle with the issue of the rarity of the disease. So we just are putting out a folio together, trying to reach every newly diagnosed family to help them gather information in one place and include information on tissue donation. I suppose we can consider consent stuff. But what would really be helpful to us is for physicians in the room who a lot of people don't know the Pediatric Brain Tumor Foundation even exists. And if physicians knew that, they can direct their patients to us, and we can really start that back and forth, because we struggle reaching 4,600 families at the time of diagnosis when they're consenting to things and they're getting tissues. We can get them a year later, but there's a lot of stuff they will not have had a chance to advocate for. So there's a real to and fro between the treating community and the foundations that I think could really use a huge boost.
I think all the Exelon investigators here, right, to get the size of cohorts that were submitted is non-trivial, right? It's like a laborious process that all of us have been challenged under. It's incredibly difficult.
One last comment before.
I just wanted to get back to something that you said before, Adam. It's this tension between the success of research and the tenure system and how we're rewarded for the work we do, and wanting to have all the data be open. And this is one of the most common questions I get fielded from foundations, which is, why don't you just put all the data in immediately, have it be available immediately? And those in the room that are reliant on getting grants and publications as their metrics of success will say, well, that we can't do that because that's not our system. So I don't have the answer to this problem, but that's going to be an ongoing tension as we continue to build these resources. Is how do we make the data available while existing in this reward system that we've created?
So just a wrap-up comment based on that. I think that there's a space for the foundations to actually start rewarding that kind of sharing behavior, and that is a real paradigm shift that we all need to work on together. And I agree, the dad, I didn't catch his name, but that said, that's a very confusing time for patients, families, when you're asked to sign a consent. However, as a brain cancer parent, I know I literally would have signed anything they put in front of me. You know your child is dying. You don't care what they're going to do with the data. So from that perspective, this is a really unique group of patients to work with because they are more willing to share their own data than, say, a breast cancer patient who, has a pretty good chance of survival and doesn't necessarily want that stuff out there. This is a really unique group, both from a patient perspective and a researcher perspective, and we're in a place where we can literally change the way research is being done, but we need to do it thoughtfully and really collaboratively. There was another point I was going to make. Oh, so as far as those expanded consents go, I don't think the problem is getting the patient families to sign them. I think the problem is literally just what those consents say, and if we can as a group go, this is the consent that we want to put out there, and this is the best practices, and that's something that foundations can certainly help spread the word on, and we can go to the hospitals that we work with and say, this is the consent we want you to use. We want it to have language like this. But it's a higher level conversation than the patients because they don't know. They don't know what expanded consent is. They don't have any ideas. And by the time they get that educated, it's way past the point where they can do something about it. So we need to start on a higher level and then take it down to them, I think.
That's great. Thanks for that comment. I think we're off to coffee break, right?
Yeah, that sounds, thank you so much for all your comments, everybody. We'll start the meet and greet now. The coffee will be in this side room here, but you can use this entire space to mingle with each other and mingle with us as NIH staff. And we'll come back at 10:30. And if you haven't uploaded your slides, please do so.